A circuit containing resistance and capacitance connected in series together is called RC series circuit. And this our experiment RC circuit. This one here is the circuit diagram of charging and discharging process of capacitor. The purpose of this experiment to study charging and discharging characteristic of capacitor to find the time constant of the RC circuit. Now, this apparatus of this experiment, we use RLC circuit, maximum working voltage 10 volt, and containing from the various resistance 10 ohm, 33 ohm, 100 ohm, and also we use voltage sensors and resistant capacitor inductor. Now, capacitor is made of dielectric material within two parallel plates. When a battery is connected to capacitor, positive charge collects on one plate and negative charge collects on the other plate until potential difference between the two is equal the voltage of battery. RC charging circuit. The figure below shows capacitor C in series with resistor R forming RC circuit, forming RC charging circuit connected across DC battery supply by mechanical switch. When the switch is closed, the capacitor will gradually charge up through the resistor until the voltage across it reaches the supply voltage of the battery. The manner in which the capacitor charge up is also shown below. RC charging circuit. This is the diagram of RC charging circuit. Since the initial voltage across the capacitor is 0, VC equals 0, the capacitor appears to be short circuit to the external circuit and the maximum current flow through the circuit restricted only by the resistor R. Then by using Kirchhoff voltage law KVL, the voltage drops around the circuit are given as Vs minus R times IT minus VCT equals 0. Now, this is a diagram for RC charging circuit curves. The capacitor now start to charge. Now the capacitor start to charge up as shown, which the rise in the RC charging curve is steeper at the beginning because the charging rate is faster at the start and then tapers off as the capacitor takes additional charge at a slower rate. This is also capacitor charging current. So mathematically, we can say that the time required for capacitor to charge up to one time constant is given as RC time constant named tau. Tau equal R times C. This RC time constant only specifies a rate of charge where R is in ohm and C in farads. Since voltage V is related to charge on capacitor given by equation Vc equal Q over C, the voltage across the value of voltage across the capacitor Vc at any sense
in time during the charging period is given as Vc equal Vs brackets 1 minus C brackets raised to power minus T over Rc, where Vc is the voltage across the capacitor, Vs is the supply voltage, T is a place time since the application of the supply voltage, and Rc is the time constant of the Rc charging circuit. This Rc discharging circuit, when a voltage source is removed from fully charged Rc circuit, the capacitor C will discharge back through the resistance R. طيب. Now, when the switch is the first closed and capacitor starts to discharge as shown, the rate of decay of the Rc discharging curve is steeper at the beginning because the discharging rate is faster at the start, but then tapers off exponentially as the capacitor loses charge at slower rate. As the discharge continues, Vc reduces, resulting in less discharging.
RC circuit, which was already discussed in the class. In this experiment, we will use this circuit, which in fact consists of the capacitor. This is the capacitor, this one, and this is a capacitor of value 1 farad. Its capacitance is 1 farad, and we use a resistance. In fact, in this circuit there are 3 options. We can use 10 ohms or 33 ohms or 100 ohms, but I will do this experiment using the 10 ohms because this will make the charging process and the discharging process faster. But we may switch to this one. We will charge and discharge the capacitor and see the value of the voltage, how it changes with time, and the value of the current, how it changes with time. In this circuit we use 2 batteries. Each battery is 1.5 volts, so this represents a voltage of 3 volts. Now I need at the beginning just to show you, I will switch to this lamp. I will switch this to this lamp and make a discharge to show you how the current starts strong, then it becomes smaller and smaller. You see the light, then it fades gradually because the current becomes smaller and smaller and smaller and smaller. Now in this circuit, since the capacitor is 1 farad and the resistance is 10 ohms, this means the time constant for this circuit RC is 10 times 1, which is 10 seconds. So we expect the capacitor to become fully charged in 40 seconds, and when we discharge the capacitor it becomes empty also after 40 seconds. Now this circuit is connected with this instrument. This is a current detector and the voltage detector. This is the current detector and this is the voltage detector. Both are connected to this spark module, which is connected to the computer through this wire, a USB connection here, and the computer will show us the data on the screen. So now I will start charging the capacitor, but first I must switch again to the resistance of 10 ohms. Now this is a switch. In this switch we can go to the charge or discharge. So this is the discharge side. So I am now discharging, and this is the charge side. So I can go like this. When I close this switch now here, it will start charging. Before I start charging, I will start recording the data here. I will press record, and we will see the curve on the screen. Okay, I will start recording. Okay, here you can see this is the curve for voltage with time, and we can see the voltage is increasing now, increasing and increasing and increasing, and I expect the voltage after 40 seconds, which is the full time, to become 3 volts, which is the maximum voltage. So I will wait for 40 seconds here, the counter, the time, then I will stop after 40 seconds. Okay, I will give 5 more seconds. Okay, I stop recording. This is the curve, this is the increasing voltage, and you can see that the maximum here, the maximum is exactly at 3 volts. Here. 3 volts, which is the voltage of the battery. This is the maximum voltage of the capacitor after 40 seconds. Now we need to record this data from this table. This table shows us the value of the voltage at any moment. So in our lab report, we need to record, in fact, these values. We need to write down what is the value of the voltage, what is the time at voltage 0, what was the time when the voltage is 0.5, what is the time when the voltage is 1 volt, 1.5, 2, 2.5, and 3, and so on. So I used the data in the table and recorded the required values in the table number 1 of this experiment. This is the table with the data inside. Here at the top are the voltage of the battery, 3 volts, the resistance is 10 ohms, the capacitance of the capacitor is 1 farad, and these are the values V with T. And in this experiment you need to make a graph with V as function of T, which is supposed to look like exactly like this one. This how should your graph look like. Now I will switch to the discharging experiment. Okay, now in the discharging part I will move this switch to the discharging side here, and at the same moment I will start recording the data on the screen. I will show you. So I will press record, and at the same moment I will start discharging the capacitor. Here you can see the voltage now starts from 3 here at this point, and it decreases, and I expect the voltage to become 0 after 40 seconds, approximately 40 seconds. So we are waiting. The time is still now 21 seconds, 22 seconds, 23. Now it's 40 seconds, 42, 43, 44, 45, stop. So this is the decreasing voltage, and you can see it's approximately 0 after 40 seconds. It's not exactly 0 because this is an asymptote. This is an exponential function. So I will do the same as I did in the charging part. I will record the data in the table and show you the data in the table. Okay, now I have collected the data from this table, and this was the result in the table number 2. Here you can see the voltage 3 volts, the resistance 10, the capacitor is 1, and these are the values of the voltage and the corresponding values of time. This is a column you need to fill yourself by calculating the logarithm of V naught over Vc. This is Vc and this is V naught, which is a fixed value of 3, and I will show you now why do we need to calculate this value, which is the logarithm. Okay, this is the equation for the capacitor voltage. We know from the class Vc is the maximum voltage, which is the battery voltage denoted by V naught in this experiment. I can divide both sides by V naught. It becomes Vc over V naught equals E negative t over tau. Now if I calculate the natural logarithm for both sides, it becomes ln Vc over V naught equals negative t over tau. To get rid of the negative sign, I can flip the logarithm. Instead of Vc over V naught, it becomes V naught over Vc. This is one of the properties of the natural logarithm, and the right hand side is t over 1 over tau, which can be written as ln V naught over C is 1 over tau t. Now this is similar to a linear equation y equal mx. If I use the logarithm of V naught over Vc as the y-axis and t as the x-axis, I will get a straight line with a slope 1 over tau like this. So in this report you will make a graph on which you will put logarithm V naught over Vc on the y-axis, t on the x-axis. You will get a straight line. The slope of this straight line represents the reciprocal of the time constant of this circuit. This is why we need to calculate this value in the table.